All right, so let's do a quick review of some fun games that I talked to you, or even ways to memorize. Oh, sorry about that. That you need to remember things. Like you've got to remember vocabulary and identifying and correct notation is really huge in geometry. So like let's think about vocabulary, like definition of a midpoint. You can sit there and say it's a point that divides a segment into two congruent segments, right? So that's when we made up that if I give you, then you give me game. So guys, if I give you a midpoint, what do you give back to me? All right, if I give you an angle bisector, what do you give back to me? See, you guys already know it. Are you with me? That's the type of stuff you need to do. If I give you collinear points, what do you guys give back to me? Think about it. Points where? Points on the same line. Don't overcomplicate things, people. It's just points on the same line, right? What if I give you coplanar points? What do you guys give back to me? No, coplanar. On the same plane. Exactly. So points on the same plane. Think about that. If this comes up, then what do you have? That's how we always think with geometry. Geometry is always an if-then thought process. If this is what I'm given, then this has to happen. If this is in my diagram, then this is what has to happen. If this is the rule, then this is what has to happen. So we always need to think that way. So today is really, we're just going to learn to identify things and define more things specifically with angles. So when I look at a diagram, I can pull them out real quick. Does that make sense? All right. So the very first thing we're going to talk about are going to be adjacent angles. Okay. When you hear the word adjacent, what does that mean in your head normally? I heard next to. A lot of you were thinking next to, or you're next to the person. So are you adjacent to the person that you're sharing your desk with? Yeah, you're adjacent. Mr. Smith and I have adjacent rooms because we share a wall. So we're going to use the same idea when we're talking about angles. So it's going to be adjacent. So here's where we're going to go. Let's write it down and then we'll talk more about it. So adjacent angles, what does that mean? First of all, that means you have two angles in the same plane with a common vertex and a common side, but no common interior, let me write that so it makes sense, interior points. All right, so let's make sure we understand kind of where this goes. They have to be coplanar. They have to be in the same plane because think about it, guys, if you look at my hands right here, my thumbs and my fingers are rays that make the sides of an angle. Could I have something like this? And would they have a common side, right? And vertex, but are they in the same plane? No, the moment I do this, are they in the same plane? So yeah, that really makes a lot of sense. So the key thing is what it says. I have to have a common vertex, and you basically have that shared side in between. So in this case, we know angle 1 and angle 2 are adjacent. So angle 1 and angle 2 are at adjacent angles. Now, another way of thinking about it, what if, and you guys don't need to write this down because I think it might confuse you a little bit more, but what if I did this and put in angle 3? My question for you, are angle 3 and angle 2 adjacent? Why not? They're not next to each other. They don't have a common what? They have a common side. They have a common vertex, but not a common side. Does that make sense? Now, how about angle 3 and angle 1? Are they adjacent? Yeah, they're adjacent because they share that common side. Make sense? Perfect. That's what I want to see on here. All right, so guess what? If you're not adjacent, you're going to be non-adjacent. I guys, you're real earth-shattering, aren't they? It's just angles that are not adjacent to each other. Now, some fun examples of this. I'm just going to put this down in the middle. We can draw a few for fun here. Could you have something like this, just floating out in space with each other? Here's angle 1. Here's angle 2. I mean, they don't have anything in common. They don't have a vertex. They don't have a common side. It's not going to happen. How about this one right here. I'm going to put a Z, so you guys make a Z with there, and have 3 and 4. Now, how do I know if something's adjacent or non-adjacent? Basically, you check it by the standards of the adjacent rule. First of all, are 3 and 4, angles 3 and 4, are they in the same plane? All right, so they're coplanar. Do they have a common vertex? The moment I go, no, that means they're what? Now, do they have a common side? Yes, but they don't have a common vertex. So that's why they're non-adjacent. Does that make sense? This case, it's all about the vertices messed it up. So can I keep it that way? So we can say angle 1 and angle 2 are non-adjacent. And by the way, I abbreviate a lot. And angle 3 and angle 4 are non-adjacent. Make sense? All right. Next definition for you guys. Here's a fun one. The linear pair of angles. First of all, pair means how many? 2. Please don't give me 3. Doesn't quite work that way. So it's 2. And linear means what? Line. You guys have already worked with these already. So it's basically a pair of angles formed from a what? A line. All right. And there's a little bit more to it, but that's the basic idea. It's a pair of angles formed from a line. So a linear pair of angles is the following. A pair of, now here's the key, adjacent angles whose non-common sides are opposite rays. Guys, you remember what opposite rays always make? What do opposite rays always make? They make a line. So remember, opposite rays will always make a line. But here's really what I want you guys to think about it. If you put them together, this side, the non-adjacent sides, should always make, or excuse me, non-common, should always make a line. There can never be a gap between these. So let me explain what a lot of people think happens. Let's just say I had a line right here. Oops, I have my highlighter yet. Glad it didn't, right. Here's a line, and I have an angle coming here. I have an angle coming here. I got angle 1 and angle 2. Are angle 1 and angle 2, based off of this definition, a linear pair? They should be no. For what reason? They're not adjacent. Right, good, guys, they're not adjacent. Now, here's the thing. They're non-common sides. Do I have a pair of sides still making a line? Yes, but they're kind of disconnected, right? They're apart from each other, don't work. So 1 and 2, circle that and slash it out. They're not a linear pair. To be a linear pair, you basically, if you put the two angles together, you're always going to form a complete line, and the angles will always add up to how many degrees? Yeah, the angles will always add up. If you're really thinking about it, the angles will always add together to be 180 if they're a linear pair. Does that make sense? So we really could use it. So just kind of keep that in mind. So again, just notation, you just say angle 3 and angle 4 are a linear pair. And the easiest way for me is like, hello, it makes a line. They add to 180, a linear pair. A lot of people struggle with these, and I know that seems really silly, but they do. They really struggle with it. All right, some few things you need to remember about notation for angles. If in doubt, use how many points? 3. So if you're not certain, use 3 points. I'm also the type of firm believer is if they give you a number, it's great to use because it saves time writing it out, right? So keep that in mind. So for example, when it says identify the different pairs of angles, I'm going to give you guys, let's say about 30 to 40 seconds to try to do as many of those as you possibly can. Go. These, all right? You need to be able to identify them, and you need to identify them quickly. Now, this is one of those lessons that drives everyone nuts. Are there going to be times answers will vary? Right? It's going to happen. This would be one of those. It's awful for grading on tests and quizzes. It takes me forever because I have to look at every single person's question perfectly. So here it says, on part A, here it says, a pair of adjacent angles. All right, raise your hand if you got a pair of adjacent angles you can give me here that you think you know. All right, yes.
Angle 5 and 7.
Yeah, angle 5 and 7 because they have a common vertex and they share that common side. Now, come on, did everyone use angle 5 and angle 7? Did any of you use something different? Katie, what did you use?
Well, I said RPS.
All right, so you said angle RPS, and what did you say? TPS?
Yeah.
Those are totally correct. So you named it with points, and that's totally fine. So angle RPS and angle TPS. Great, good choices. But notice both are correct. One just named it with 3 points, one did it with numbers. Are you guys still good? Do they have a common vertex and a common side? Yep, so it's very good stuff. Excellent. Okay, now, a linear pair of angles. Now, this is kind of cruel. Like, all of you can see the lines. You guys see the couple lines that are drawn? So you know you have options, but you're gonna make sure that you fill it in correctly. Who thinks they've got a linear pair here for me? They might know. All right, Michael. Angle 5 and angle 6, very good. Do you guys see how he used this angle and then this one together? Did anyone use any different than that? Any different? All right, Gloria Grace, what'd you get?
Finding the points, I said angle RPS and angle SP.
Very good. Do you guys agree with Gloria Grace? Because if I put them together, she just used this line right here. Didn't she? So is that a correct way of doing it? Totally. So let's write hers down as well. So another option we could have used was it RPS and angle SPU? Make sense? Did anyone pick different than that? All right, Cora, what'd you pick?
I did angles PR and RPT.
And you said RPT? Yep. And angle RPT. Excellent. There just can't be any gaps. How about angle 8 and angle 7? All right, now it says name another pair of angles. Guys, I think we've already done that. What do you guys think? Right, Claudia, do you have another one?
I have a question.
Yes.
So can you say like a linear pair that would be like segment, or would that be?
No, because P is a vertex, so it wouldn't work, and P works for all of those angles. Remember, if I have a vertex, I can't use just it itself. So you could use like QPS and angle 7, and that would be okay. Does that help? All right, awesome. Good stuff. Now, guys, you just had to be able to work with those. Now look at the next one. It says true or false. Angle 8, angle RPS, and angle 7 are a linear pair. What's your answer for that? What's the reason why it's false? This is really easy. Yeah, it's not a pair. 3 is not 2, right? It just doesn't work. How about angle 8 and angle RPT? So this one and here to here. Do they make a linear pair? Yeah. So that's going to be a true statement. They're not bad. You just have to make sure you have adjacent and you have linear pair down. And non-adjacent also would work. All right. I'm going to tell you right now, if you can figure out linear pair sooner than later, your life is awesome because we use it all year long in here. And this next one is also used all the time. They're called vertical angles, okay? So make sure you get this definition out because this makes a huge difference. So vertical angles, first of all, are going to be two non-adjacent. So two non-adjacent angles formed by, and this is it, two intersecting lines. So two non-adjacent angles formed by two intersecting lines. All right, so let's get this to the easiness of we possibly could on this one. When you two lines intersect, we know two lines intersect at a what? Two lines intersect at a vertex, or they intersect at a point? Now, which makes the vertex for the angles, right? So two lines intersect, because when two lines intersect, that's one of our postulates, right? Two lines intersect, they intersect only at one point. So, you will always form four angles. And now, obviously, to make my life easier, I called it 1, 2, 3, 4. Now, what do you know about angle 1 and angle 2? What's so special about them? How would we describe them? They're adjacent and they're a linear pair, right? Okay. How about 1 and 4? Same thing. They're adjacent and they're a linear pair. Well, what's the only one that it's not adjacent to? 3. So that's why I know then that angle 1 and angle 3 are vertical angles. They're formed from the same two lines, and they're the only ones that are not adjacent. So then the same thing goes when you're working with 2 and 4. 2 is adjacent to 1 and 3. So the only option it has to be a vertical angle with is which one? 4. So that's why we know angle 2 and angle 4 are vertical angles. Now, friends, we're going to learn a lot of rules about vertical angles and stuff that are so helpful. So make sure you can identify them, because when you get stuck on a problem in like second semester geometry, I'll look at you and go, well, did you use vertical angles? Or I'll say, oh, did you use a linear pair? And you go, and most of the time you get to the point where you're like, yes, I did, Mrs. Gregerson. If you don't, I'll be like, too bad, because that's what we're going to do. So you have to be able to identify these. So let's do this real quick. So anytime that two lines intersect, how many pairs of vertical angles should you get? You should always get 2, right? 2 when they intersect. So guys, let's name these real quick. Name an angle first. Let's just do this real quick. Solomon, name an angle for me real quick. On example 3. Angle what? Or did you just said angle M? Is that correct notation? If I have more than one angle coming from a vertex, can I say just the vertex? No. All right, so give me another angle name. Angle what? Now I'm with you. All right, so angle HMJ. Now, if I'm talking about angle HMJ, what is it's going to be? Its vertical angle pair. Which one goes with it? Hannah. Yeah, an angle LMK. Awesome. So these two are the ones that are going to go together. All right, well, guys, what's left for the other pair then? Yeah, angle HML and angle JMK. Yeah, they're going to be the ones that go together. All right, you ready to throw a wrench in it and really complicate things? What if I give you a diagram that looks like this? Let's have a little bit of fun now. All right, I think it's fun. Please identify the following pairs of angles using the diagram below. I honestly did this, so you really have to be good at picking things out. All right, it says I want a linear pair of angles. A linear pair of angles. Now, guys, if you get this one wrong, it's pretty common for the first try. But does anyone have an idea what would be a linear pair of angles that you'd work with? Yeah, SJ. You said angle CAB. And which one? And CAG. Very good. Because I'm going for here, and then I'm going all the way over. Correct? Notice, can I ignore the 2, 3, 4, and 5? Yeah, I have to make it so they're adjacent, guys. Remember, they have to form a line. And they have to have the common side between them. Notice when I highlight it like that, it's so much easier to see the linear pair, right? So yeah, make sure you know those. All right, awesome. Good. Now, are there other linear pairs you could use? Did any of you say angle like 7 and 6? Could I have used angle 7 and angle 6, the two bottom ones? Or now, I could have named them with points as well, but either one of those work. Awesome, good job. Thanks, SJ. All right, adjacent angles whose sum is 90 degrees. So I want two adjacent angles whose sum is 90 degrees on this one. Give me that, Trevor. Angle 4 and 5. Excellent. Guys, don't make it hard. Just remember, what does the box always mean? 90 degrees. Perfect. Okay. Adjacent angles that are both 90 degrees. Adjacent angles. Yes, sir. You said angle 6 and 7. Now, I'm going to say he's absolutely correct, and I haven't taught him the rules yet. Because here's the thing. If this whole thing goes to 180, doesn't 6 have to be 90? Doesn't it? So now think about it this way. if 6 is 90 degrees, what does 7 have to be? 90 degrees, because what do the two of them have to add together to be? 180. Excellent. All right, so angle 7 and angle 6. Could I also have said angle EAG and angle 6? Would that be an option? So like you have more than one. Again, answers will vary, so you kind of have to trust yourself, but use correct notation. Notice every one of these, does it have an angle symbol with it? So if you name it without an angle symbol, you're going to get it wrong automatically, and I'll be like, oh, too sad, too bad for you. You didn't do it right. All right, that's what happens. So you make sure you have it. All right, a pair of vertical angles. I need a pair of vertical angles. Now remember, what makes vertical angles? I have to have how many lines? I need 2 that are intersecting. So notice, you got to pick out 2 lines that are actually intersecting to do this. Who thinks they've got an answer for me on this one? Who thinks they've got it? Joshua.
Angle EAG.
You said angle EAG?
And angle 7.
And angle 7. Good. Now notice, what did I do when he named those? Notice I highlighted them. And the moment I highlight them, do you guys now see the intersecting lines? Now be really careful with those, that you don't name ones that aren't intersecting. So you said angle 7. Make sure, oh, I still got highlighter on. So you said angle 7 and angle EAG, is that right? Were there another pair I could use for this? Is there another, Hallie, what's another pair I could use?
You could do angle EAG.
Awesome. Yes, ma'am. No, they have to be from the same line. So let me show you why 4 and 7 don't work. So when you're doing angle 4, I'm glad you're asking that, because I wanted to show an example of that. So you made me happy. Way to help. And then if I look at angle 7, are they being formed by the same lines? No, because if they're intersecting, they're going to get that perfect V shape, right? So if they don't make that perfect V with 2 lines intersecting, they don't count. So that's a good question to ask, because she asked if angle 7 and angle 4. No, because they don't have the same lines intersecting. Yes, Gloria Grace.
Is there a way to write like angle 4-5 angle 7?
Nope, you're going to have to use it with 3 points. Yep, you're going to have to say angle EAG. No, darn, no. It was worth trying. It's worth trying. But guys, does that make sense? All right, well, here's my question. How many vertical angle pairs were there in this diagram? How many total do I have? Just 2, right? So I just only have 2 here, and we named them both, which is kind of nice. 2. Now, here's a question, Mrs. Gregors. Oh, no, let's go down here. I'll have fun. Let's do a multiple choice question you guys try. Which 2 angles are vertical angles? F, G, H, and J. Can you tell I stole this from Sesame Street? All right. This is not A, B, C. Which 2 angles are vertical angles? All right, everyone shout it out once. What's the answer?
H.
All right, angle H. We have angle RPQ, and we have angle TPU, those 2. Okay, now that was our option, but was there any other vertical angles though? What's the second pair? Because we know there should always be how many pairs if I do this, guys? Should always have 2 pairs, right? If I have lines intersecting. So where's my second pair? What do we got? Cora.
RPT, angle RPT, and angle QPU.
And yeah, QPU. Guys, you see the ones, I'm going to put this in red here. From here to here, and there to there. Does those make sense? All right, so today's homework is not real bad, because are we just really identifying stuff? We're identifying stuff, and then I have you reviewing some of the other lessons to help prep for the quiz. All right, now, we're still having struggles, guys.